Hello, in this video we will show how to train a logistic regression model using scikit-learn package in Python. So we know logistic regression is to model the probability of a positive event. So this event's probability is P, and the odds, which is the ratio between the positive event and the negative event, their corresponding probability. So this is the positive event. For example, the patient has a cancer's probability, and 1 minus P is the probability that he has not cancer. So this is the odds, and log means the log odds, the logarithm of the odds. And the logarithm of the odds also equals the net input in the model. Now, net input is the parameter and features, the projection, and the plus BS. So this is the logic, but we are interested in the probability, right? So this function called sigmoid function, then this is the logic part, because Z is the net input, which is the logic. Then 1 divided by the 1 plus the e, the power of negative logic. So this result called sigma Z is the probability of positive event given the Z. So Z is the net input, which combines the parameter and features value. So from this given information, the probability is what we are interested in, right? So this is the logistic regression to model. The purpose is to learn the parameters. Then we can calculate the probability and to get the final predicted label. And this part is the training process. So before this arrow, training procedure. And we get the net input from the feature, from the weights, initial value. Then they project together, and the plus BS is the net input. Then this is the activation function, which is the sigmoid function we have shown in the previous page. Then we get the probability for the positive event. Then this part will compare with the opposite of the label, 0 or 1, they will get the error. Then take this error, sigma together for all the samples, will get the loss function and will be updated with parameter weight and BS from the optimization technique. So after the training procedure finished, then we get the final value for the B, for the BS and the weights. Then we can calculate again for one time, and with a threshold. For example, the probability larger than 0 will be 1 for the final label, otherwise it will be 0. So this is the whole process for the logistic regression. And next we will show how to implement this logistic regression with the scikit-learn package in Python. So if you are interested in, you can download this file from this link. You can try it later. So next we go to this file in Python. So first we set the working directory and load these packages. Then we download data for the ELIS. We get X and Y value. X is here we just use the second and third features. Sorry, the third and fourth features, and Y is from the target attribute from this ELIS dataset. And we'll show how many classes in the Y. There are 3 classes. Then we can get training and test data using train test split function with the 30% for the test and the 70% for the training, and with the stratify yes. And we print the data for the training and test. They have kept the original percentage for 3 labels. Then we scale the training and the test data. Then they have the same mean 0 and standard deviation 1. So next we just skip the perception part. Then we create a function called plot decision region, because after the model is trained, we will show how it is going with the real observed values and the model's decision region. So in this function, the first part is to plot the meanings of points in the map, then predict these points label from trained model and show different colors for these points. So usually this will show a map with a straight line. On the other side of this line will have different colors because they represent the different label value from the prediction. Then in the second part of the code will show the observed points also with different colors. So we can compare observed parts of the points with the model parts. So we just run this and we'll use this function later. Here we just combine the training data and the test data together. Here we do not show this now because this is for the perception, and we also skip the sigmoid part because of course we can use this, but this is not directly connected with the scikit-learn part. We can just skip those because this is the logistic regression with we just not using scikit-learn. So in the scikit-learn we not use this class. We can just skip for now. But for the data we can use this one. So next is for the scikit-learn. For the scikit-learn, you can use logistic regression from the package. Then here is the hyperparameter regularization parameter C is 100, and a solver and a multi-class use OVR. Then this instance is created. Then we can train for X train, STD, and Y train using the fit function. So it is done. So next we can show the print the decision region, plot the decision region, this function, and with the combined X for test and training data combined, and with Y combined also, and using this trained module. Then we set the test data from 105 to 150. Then the label will show how it is going. So this is the decision region, 3 region for 3 classes in the original dataset from this map. So this 3 region with different color means there are millions of points which are predicted by the model and show with different colors. Then these points are the real observed points. You can see this is misclassified because this should be in the blue region but in the green region. So, but the accuracy over 99%. You can also use this trained model to predict. For example, we predict the test data set, the first 3 observations, and use all the features. You can see how it is going. So the result is 3 line in array, 3 row, 3 column, right? So this is one row, this is second row, and this third row. So each row represents 3 probabilities estimated for this observation. So for example, this is for the Virginia cat, this is vesicular, and this another class. And the same for the second observations, predicted classes label, and this is for the third observation. And you can also use the predict probability function using this with this test input. Have to sum together. We see how it's going. Sum together the 1, 1, 1. So this is correct because this is for each observation's 3 classes probability together. And you can also use argmax function to get the label, because we will choose the one with the largest probability, then we'll get this index. Show how it is going. So for 3 sample, the first sample will be class 2, and this is the largest class, the third class, right? For 0, 1, 2. So this is the third class. And for this other 2 observation, we will get the predicted label is for the first class and the first class. And you can also use predict, say, same. And if you want to use the only one observation, because here is 3 observations, so NumPy will automatically reshape this as a 2-dimensional. But if you use 1 observation, NumPy you have to use the reshape function to make this 2-dimensional before using predict function. So here we use reshape to the set 2-dimensional, and for 1 observation, the result is this observation results for the class is third class. So thanks for watching.